We're always asking if an AI is giving us the right answer. But what if we're asking the wrong question? What if the real question is, did it get the right answer for the right reasons? Today, we're going to dive into a completely new way of thinking about AI, a way to make sure it isn't just correct, but that its logic is actually provably true. See, the big problem we're facing with a lot of today's AI is this gap between a plausible explanation and a verifiable computation. The AI can spin this incredibly convincing story about how it reached a conclusion. I mean, it sounds right, it feels right, but underneath, its reasoning could be built on a total foundation of sand.
And this really gets us to the heart of the matter. When an AI shows its work, can you actually trust what you're seeing? This is what researchers call the faithfulness problem, and it is a massive roadblock for using AI in super high-stakes areas, like medicine or finance, where a plausible but wrong line of reasoning is just not an option.
Think of it like this, okay? Imagine you're grading math homework. On the left, you've got a student who shows every single step. It's logical, it's clean, it makes perfect sense. But on the right, you've got a student who somehow stumbles into the correct answer, but their work is complete nonsense. They're trying to subtract like 60 apples from $500. The number at the end might be right by sheer luck, but the logic is totally broken. And that is exactly what AIs can do. So this is the crucial takeaway right here. The biggest danger isn't always an AI that's just plain wrong. No, it's the AI that gives you the right answer, but for all the wrong reasons, and then wraps that flawed logic up in a beautiful, plausible, human-sounding story. How in the world do you even start to fix that?
Well, the solution, and this is where it gets really cool, it comes from a truly fascinating and pretty radical idea that connects the worlds of mathematics and computer science in a really profound way.
It's something called the Curry-Howard correspondence. And the big idea here is that a formal mathematical proof and a well-written computer program are, well, they're basically the same thing. They're two sides of the same coin. A proof is a program. Now, if that's true, it means we can actually check an AI's chain of thought, just like a computer compiler checks a piece of code for bugs.
And this right here completely flips the script. We can stop treating an AI's explanation as just a story that we have to read and take on faith. Instead, we can start treating it like a computational process that we can formally verify, step by logical step.
So that's the theory. It's a beautiful idea, right? But how do you take that and actually build it into something practical? How do you apply it to the often messy, natural language reasoning that comes out of an AI? Well, a group of researchers developed a new method they call proof-carrying chain of thought, or PCOT for short. And its goal is spelled out right here in this quote. It's all about building a solid bridge from the kind of fuzzy, sometimes black box reasoning of AI to the crystal clear, rigorous world of formal logic.
And here's basically how it works. First, the AI does its thing, generates its chain of thought. But then, each and every single step gets type-checked for logical validity. It's making sure you're adding dollars to dollars, not dollars to apples. Then, all the valid steps get linked together in a kind of reasoning graph. And finally, the whole chain only gets certified if there's a complete, unbroken, logical path from the starting facts all the way to the final answer. But what's really clever here is that this isn't some all-or-nothing system. You can actually tune it. You can use what's called a relaxed gate, which allows for a bit more exploration, or you can switch to a strict gate for those really high-stakes tasks where every single step has to be absolutely perfect. It's like having a control knob for trustworthiness. Okay, so this all sounds great in theory, but does forcing an AI to write a verifiable proof instead of just a plausible story actually work in the real world? Well, the results are, to be honest, pretty astonishing.
The researchers put this to the test on a notoriously difficult math benchmark called GSM-8K. It's packed with these multi-step word problems that are designed to trip up even the most powerful AI models out there.
So first, let's look at the baseline. A standard, powerful language model without any of this certification gets the answers right less than 20% of the time. Yeah, not a great score.
But what happens when you take that exact same model? You don't make it any smarter, but you just add one rule. You only accept the answers that can be certified as logically sound programs. The accuracy skyrockets to nearly 70%. This isn't just some small improvement. This is a massive, massive leap in performance, and it comes simply from filtering for verifiable reason.
I mean, just look at this visually. The difference is it's dramatic. We're talking about a more than 50 percentage point jump in accuracy. The AI's core ability didn't change at all.
But by forcing its reasoning to be verifiable, we can reliably pick out its good logic from its bad. And that just transforms its precision.
And this is about so much more than just getting better scores on a math test. This really points toward a future where we can begin to build AI systems that we can genuinely, truly trust.
The benefits are really threefold. First, you get verifiability. The explanations can be checked by a computer, which removes human error or bias from the equation. Second, you get compositionalizability. Huge, complex problems can be broken down into smaller, provable steps. And third, and this is huge, you get debugging. When the logic fails, the system tells you exactly where the mistake happened.
At the end of the day, this is the key takeaway. It is a fundamental shift in how we think about this stuff. We are moving away from treating AI explanations like these plausible stories we just have to interpret, and we're moving towards treating them as verifiable proofs that we can actually trust.
So I'll just leave you with this one thought. What would our world look like if every single time an AI gave us a critical answer, it was required to provide not just its work, but a formal, verifiable proof that its logic is absolutely sound? That could be the future of truly accountable AI.